Hey guys, this is Mr. Urrego, and today we're going to do rational exponents and radicals back and forth. Like I said in the previous video, all about radicals, by the way. If you haven't watched that video, please watch that one first, all about radicals. And that is a more basic video than this. This is going to be a little more advanced than the previous one. Alright, so watch that one, and then come back to this one. So, like I said over there, radicals and rational exponents are family. They love each other, so they help each other, and independent of the problems, we either use the rational exponents or the radicals, or we go back and forth like I'm saying right now. So first of all, let me rewrite it. So let me show you what's the relationship. So let's pretend that I have let's say cube root of x to the second power. Okay, if I have this radical and I want to rewrite this as rational exponent. By the way, why rational? Rational means fraction, right? You have to relate that. That means fraction. So rational numbers are numbers that you can write as fractions. I'm sorry that I threw that in there. So rational means I'm going to write this with the exponent being a fraction. So how does that work? Let's get this. So let's say that I have this x squared. I'm going to bring in the same thing, x squared. My index is going to come up, that 3 is going to come up dividing my exponent. So cube root of x squared is the same as x to the 2/3. Alright, that's the idea. Let's say that I have another one. Let's say 7 root of x to the 5th power. My power comes out the same thing. The index is the one that comes dividing. So radical form, rational exponent. Radical form, rational exponent. The denominator, the number that is divided, that's your index, whatever index you have here. Okay? That's the idea. Remember, if I don't have an index, right, that means I have a tiny 2 that I don't write, because we read this as square root of x cubed. Square root, supposed to be there too, but we don't write it. Okay, so this is the first thing. All right, let's start by simplifying. So let's simplify. Let's start with 64. Okay, so that means x square root of 64. For the most part, you know this already, because 64 is a perfect square. Square root of 64 is 8. Right? Why? Because 64 is the same as 8 times 8. So if I want to write this as a power, I'm going to have 8 to the second power, because I have 2, right? That's why I have a 2 here. I have 2 8s, so it's a squared. Okay? So let's go back and forth. If I'm going to write this as a rational exponent, then I have that 64. Let me rewrite that as 8 to the second power. Instead of 64, I'm going to write it as 8 to the second power. Okay, and now let's rewrite it. Alright, so I have my power and my index. If there's no number, you have a tiny 2, comes dividing. 8, 2 divided by 2, 8 to the first power. Whenever I have a rational exponent, okay, and this has to be on your notes. Whenever I have a rational exponent, right, and then it's simplified to a whole number, that means that number is on the outside of the radical. It's no longer inside a radical. If you have a, let me give you an example. If you have a rational exponent that is a fraction, that means that is still inside a radical. So if I rewrite this as a radical, then look, right? That's the power, and my index is a 3. Okay, so fraction as the exponent, that means a radical. Whole number, it's outside the radical. Keep that in mind. Let's go with the 64. So let's say that I have 64. Let's do 64 again. But instead of square root, let's do cube root 64. Okay. Now, unless you know your perfect cubes, I gotta do something now. Okay, what do I do? First of all, I'll bring the 64. Let's put it right here. And I gotta break the 64. So the easiest way that I found how to break numbers is divide by 2. 64 divided by 2 is 32. So 32 times 2 is 64. We're doing prime factorization just in case. Or this is called also tree factorization. Again, two numbers that multiply get 32. 2 times 16. What I'm doing is 32 divided by 2 is 16. 16 times 2 is 32. Let's keep going. 2 divided by 16 divided by 2, 8. 8 divided by 2, 4. 4 is 2 times 2. Alright, that's my tree factorization. Easy. Divided by 2, divided by 2. If not, divided by 3 or by 5, and any prime numbers. Okay, let's rewrite it. Let's revise this. How many 2's I have? 1, 2, 3, 4, 5, and 6. So 64 is the same as 2 to the 6th power. Here we go. So instead of the 64, I'm going to write cube root of 2 to the 6th power. And I'm going to rewrite it as a rational exponent. Alright, 2 to the 6th power. Let's make a point right here. Blue. 2 to the 6th power comes out. My index, will divide my exponent. Okay, therefore 6 divided by 3, the exponent 6 divided by 3 is 2. 2 squared, 2 times 2 is 4. Oh, so that means cube root of 64 is 4. And you didn't have to do the perfect cubes, just we did exponents. Alright? Okay. Remember, as soon as I have a whole number as my exponent, that means a number that is outside the radical. Let me give you a different example. So now instead of cube root, let's do 4th root, or 64, because we already broke it in. So we have that already. Instead of the 64, I write 2 to the 6th power. Okay, let's rewrite it as a rational exponent. My power, 2 to the 6th, comes out. My index divides the exponent. Oh, okay, but there's something weird going on. I can reduce that. 6 and 4, half and half. Half of 6 is 3, half of 4 is 2. Still, can I do something with this thing? This is a radical because I have a fraction as an exponent. I don't have a whole number like I have here. If I have a whole number, I just get a number out of the radical. But here I still have a fraction. If I want to write this as a radical, look what I have. I have square root of 2 to the 3rd power, right? Looks weird. I can do something with it, yeah, but it didn't come up, the whole thing. It's not like a whole number right now. So what do I do now? Here we go. So we need to play around with that exponent. Let me show you. Okay, so I clean up the screen because we need space right now. So here comes the most important part of the whole video, this video. You understand what's happening next? You get the whole idea. Now, we know powers, and we know the property of exponents. If we don't, well, here we go. Every time you have 2 powers, and you multiply them, what do we do with the exponents? You add them, right? 2 plus 3 is x to the 5th power. We know that. What about if I have x to the 5th power, and now I need to break that exponent? So we go backwards. So I can rewrite this x to the 5th into 2 powers. Any 2 powers that add up to 5. So I can write x to the 5th as x to the 4th times x to the 1st, as x to the 3rd times x to the 2nd, as x to the 2nd times x to the 3rd, or at x to the 4th times x to the 4th, right? I'm going backwards. Why am I doing this? Because I'm going to use this property in order for me to take something out of this radical. All right? So what about if I have 2 to the third power? Can I break that into 2 to the second times 2 to the first? Yes, right? So I'm going to do that in here. Square root is the same as 2 to the second times 2 to the first. If you watch the previous video, then you know what I'm doing right now. Why is this? Because now I can break that into 2 radicals. Remember, there's no index, you have a 2, right? Why am I doing this? Because now the exponent is going to divide the index. So let me rewrite this. This is going to be 2 to the second divided by my index, which is 2. Here, 2 and 1/2. 2 divided by 2 is 2 to the first. It came out to be a whole number. As soon as I have my exponent as a whole number, it's out of the radical. What about here, 1 divided by 2? Is 1 bigger than 2? No. Can I divide 1 divided by 2? You can't. So because you're not able to do this, you go back to the radical. 2 to the first and my square root. So my final answer for this is 2, because 2 to the first is the same as 2, square root 2. So when I have 4th root of 64, we did all this process. We ended up with a square root 2 to the third. Then we broke this out, and then I ended up here. All right, so that's the idea. The idea is that when you have a power that is bigger than my index, I break it into groups, okay, using this property. Let's do another one. Let's use this space. So what about if I have cube root of x to the 5th power? I see that my exponent is bigger than my index, therefore I'm able to. So the same thing that we did here, remember the x to the 5th? So that means I can break that x to the 5th, don't forget the index, into x cubed times x squared. And because I have a product on the inside, then I can break that into x cubed times x squared. Again, I explained all this in the previous video, so please go back to that one. Also, one more thing, if you're learning this thing, guys, subscribe to the channel, like the video, and hit the notifications bell, because this is a process, okay? Next video will be the next step of all this. Let's go back to it. So, I have this. I broke it into x cubed, x squared. Why am I doing x cubed? Because my index is cubed. Let's rewrite. What's going to happen here? X to the third power and my index divide the exponent times here x to the second power, my index will divide my exponent. 3 divided by 3 is 1. That came out of the radical. Here, 2 divided by 3. Can I divide 2 by 3? No. 2 is smaller than 3, therefore that's not coming out of the radical. So I go back, x squared, and my index is my denominator is my index. Don't forget. And that's my final answer. Let me explain something. When we're doing radicals, when we're doing variables, all right, we're doing variables, but this is a cube root, so this is fine, positive, negative. Let me give you an example, something with variables to make sure that this is clear. So let's say that I have square root of x to the 5th power, okay? No index, I have it too. Let's put it there so we can think about it. Okay, I need to break that 5. I need to break that 5, right? Into something that's going to help me out. Now, my index is 2. How many groups of 2 I have into the 5? 2 times 2 is 4. So I can break that into x to the 5th into x to the 4th times x to the 1st. 4 plus 1 is 5. So 2 powers. Let's put the 2 just in case. So we make sure that we understand that we have index as 2. What's next? 2 radicals. 4th, first. Why? Because my exponent will divide the index. So I have 4th divided by 2. Here, hopefully by now you understand that this x is not coming out, right? Why? Because I have 1 and my index is 2, right? I cannot divide 1 divided by 2. Therefore, that comes back to the radical. It goes back to it because the 1 is not bigger than the 2. Here, 4 divided by 2, I get a whole number. So that came out of the radical. All right? As soon as you get a whole number as my exponent, that's out of the radical, and this is my final answer. Okay, let's try something else. So let's review a couple properties from previous video. I'm dividing 2 radicals. Remember, I'm dividing 2 radicals. Both of them are square roots. I can put them together into 1. One thing before I move into this. Why am I putting them into 1? Can I do square root of 6x? Is the 6 coming out? Is the x coming out? No, I only have 1. And remember, my index is 2. So that x is not coming out. So this becomes a problem to solve this. X cubed. Okay, something is coming out. 48. I gotta break the 48. So an easy way how to do it is, when I have radicals, I have 2 radicals, 1 divided by another one. Same index, 2 and 2. I can put them together into 1. Both of them come in as a fraction on the inside. Why am I doing that? Because then I'm able to simplify on the inside. 48 divided by 6 is 8. X cubed divided by x to the first. What do I do with the exponents? Subtract. 3 minus 1 is 2. And look at this. This big or horrible problem became something really simple. Now I know that that x is coming out. Why? Because my index is 2. 2 divided by 2, that's coming out. Let's break the 8. 2 times 4 is 8. Alright? As soon as you see a big number inside a radical, you need to understand that you have to break it into prime factorization. You have to do this. How many 2's I have? 3. So let's go back to this problem. So that's the same as, I'm not going to put the index again. By now, oh, come on, okay. By now, we need to remember that. So, 2 cubed, x squared. Index is 2. That 3 has to be broken as 2 to the second times 2 to the first times x squared. Okay, why am I doing this? Do I need to break every single one of them into a radical? No. Okay, I can either do this, right? The first one times the second one times the third one, or I can just say, listen, 2 divided by 2 is going to be, this is an equal. 2 divided by 2, 1. Oh, whole number came out of the radical. 1 divided by 2, is it possible? My exponent divided by my index, 1 divided by 2, is possible? No. I know that stays on the inside of the radical. The x, 2 divided by 2, yes, came out. Again, 2 divided by 2 is 1, came out of the radical. 1 divided by 2, you cannot, so goes inside the radical. 2 divided by 2 is 1 and it came out. Final answer, 2x is square root of 2. Alright? So you don't have to break into every single one of them. You did, that's fine. 2 divided by 2 is possible. 2 to the first. 1 divided by 2 is not possible, so I push it back always. And now 2 divided by 2 is 1, and here we go. Same answer. Okay? Again, we go back and forth. You're always thinking on rational exponents when we're doing radicals. I'm trying to send that message. Okay? Hopefully we get the idea. Let's do another one. What about if I have 2 cube root of 24x cubed times 3. Again, my index has to be the same. In order for me to do any of this, my index of the radicals have to be the same. 10x to the 5th. I'm multiplying 2 radical expressions. Alright, here we go. When I do that, let me bring the red. The number on the outside, this is called a coefficient, right? This is the coefficient for this radical. The 3 is the coefficient for this radical. So the numbers on the outside multiply each other. 2 times 3 is 6. Numbers on the inside multiply each other. Cube root of numbers on the inside. So I always say outside with outside, inside with inside. You'll never multiply something that is on the outside with something that is in the inside of the radical. Never. Okay? Make sure that, put that note somewhere. Outside, outside, I got a 6. 24 times 10 is going to give me 240. X cubed times x to the 5th. I add the exponents. X to the 8th. I hope you're seeing that 8 and that 3. Oh, that's not divide, precisely. So I got to do something. First things first, I got a 240. Bring the 240 here, and here we go. You can break the 240 any way you want. I always divide it by 2. 120 divided by 2. 60 divided by 2. 30 divided by 2. 15. I can divide it by 2, so 5 times 3. Why do I do that? Because look at this. This is a beautiful pattern. I can see all spread out. All my numbers are spread out. Okay? And remember, when you're doing prime factorization, you have to look at the, what am I doing? Blue? Let's go with red. When I'm doing prime factorization, I look at the branches. You see this branch, the branches? Be careful. The branches are going to give you the prime factorization. All right? So people get confused here because they look at this one too, and they get the 60. No, but the 60, I broke the 60, right? I broke the 30. So these numbers on the outside are the ones that you're looking to. So 240 is the same as 5. How many 5s I have? Only 1. 5 to the first power. How many 3s I have? Only 1 3. Oh, come on. Hold on. There you go, better. And let's go, how many 2s I have? 1, 2, 3, and 4. So this is the prime factorization of 240. So let's bring it over here. Cube root 240, 5 to the first. So we know that is not coming out. 3 to the first, not coming out. 2 to the fourth. Is that coming out? Yes. It's bigger than the 3. And x to the 8th power. Bigger than the 3 is coming out. So let's make those groups. Okay. I'm going to keep those. Cube root of 5 to the first. 3 to the first, not coming out. 2 to the fourth. I make it into 2 to the third times 2 to the third. To the first, I'm sorry. 4 is 3 plus 1. Why 3? Because it's going to divide with the index. X to the 8th. How many groups of 3 I have in the 8? 2. 2 times 3 is 6. X to the 6 times x squared. Alright, and I don't know what was going on. I'm going all crazy. Alright, let's see what's coming out. Is this 5 coming out? No, I only have 1 and I need 3. So it goes back in. Is the 3 coming out? No, I only have 1. I need 3. Is this 2 cubed coming out? Yeah, 3 divided by 3 is 1. I get a whole number, comes out. 2 to the first stays on the inside. X to the 6. 6 divided by 3 is 2. It came out. X to the second. No, I have 2 and I need 3. That goes back in. So as soon as I take whatever I can out of the radical, the outsides will multiply, the insides will multiply. 6 times 2, 12, x squared. Cube root of 5 times 3 is 15, times 2 is 30, x squared. And this is your final answer. Okay? So as we can see, hopefully you understand by now how do we break those numbers and, those groups come out. Okay, here we go. Now let's talk about rational exponents. The properties are the same. The property of rational exponents are the same. So here we go. So let's clear this out. So same as before, my properties are the same. You have to keep that in mind. X squared times x cubed. What do? I add the exponents. I will be going back and forth with this. What about rational exponents? Okay, x to the 1/2 times x to the 1/3. What's going to happen with the exponents? The same thing here. They added, so I have 1/2 plus 1/3. The problem is adding those exponents. Okay, I'll link a video about fractions, all about fractions underneath. Here we go. What about if I have two powers? I multiply, right? 2 times 3, I multiply the powers. What about if I have two powers with rational exponents? X to the 1/2 to the 1/3 is the same as, what do I do with the exponents? 1/2 times 1/3. And this is simple because when you multiply fractions, is the top with the top, 1 times 1, and the bottom with the bottom. 2 times 3 is 6. So this is my answer. Again, anything to the 0 power is 1. What if I have a negative exponent? Right? This is a fraction technically. If I have a negative exponent, I flip it. If it's on the top, it goes to the bottom. Same thing applies with a rational exponent. If I have a negative rational exponent, what do? Put over 1. And if I have negative exponent on the top, it goes to the bottom. By the way, this doesn't look like an exponent. I'm sorry about this. 1 over x to the 2/3. There you go. A little better, I think. I'm trying to do, the bigger so it shows up in the screen. What about we divide? X to the 5th divided by x cubed. I subtract the exponents. 5 minus 3 x squared. If it's rational exponents, same rules apply. X to the 2/3 divided by x to the, let's say 1/2. Right? What do I do with the exponents? Subtract them. 2/3 minus the bottom. Here comes the problem. Right? So let me give you examples with this. Here we go. So same as with the radicals. Let's start by simplifying. So let's say that I have, let's get red. If this is going to give me a red, come on, there we go, red. Let's say that I have 125 to the 2/3. Okay. Same as radicals. I have a big number. I bring it on the side and I break it. Can I divide it by 2? No. By 3? No. By 5. 125 divided by 5 gives me 25. 25. 5 times 5. You can use a calculator to break this if you want. 125 is the same as how many 5s I have? 1, 2, and 3. 5 cubed. So instead of 125, I write 5 cubed. Oh, but I have also a power on the outside. So put a parenthesis, and I put the second power. What do I do with those exponents? Power of a power. I multiply. Because I have a fraction on the outside, I make a fraction my exponent. Alright? So let me bring those two fractions on the side. So I have 3 times 2/3, right? I need to understand that I multiply the powers. Bring the fractions, make it a fraction. How do I multiply this? Top with top, bottom with bottom. 6 divided by 3. So 5 cubed to the 2/3 is the same as 5 squared, which is 25. What about 32? Let's do this. 32 to the -4/5. Alright, couple of things. One, we can break the 32 right away. Or second, you understand that I have a negative exponent, so I bring everything down. All the power down, and now my exponent is positive. What's my next step? Break the 32. half 16, half 8, half 4, 2 and 2. 1, 2, 3, 4, 5, 32 is the same as 2 to the 5th power. Let's keep going. 1 over, let's break the 32, let's rewrite it as 2 to the 5th power. But I also have another power. Wow, what's going on with this parenthesis? Right. I replace the 32 by 2 to the 5th and parenthesis to the 4th. Exponents, what do I do with them? Multiply them. Okay, so I got 5 times 4 over 5. This 5, make it a fraction over 1. 5 times 4 is 20. 1 times 5 is 5. 20 divided by 5 is 4. So 2 to the 5th to the 4th, 4 over 5, becomes 2 to the 4th power. When I multiply those two exponents, I ended up with the 4. You want to solve that. 2 to the 4th is 2 times 2 times 2 times 2, 4 times. 2 times 2 is 4, times 2 is 8, times 2 is 16. Final answer. So if you notice, my properties are the same. The problem here is that I have fractions. Alright, so I need to know how to multiply fractions. Or, like in this case, let's see what's going to happen. So another example, I have, let's multiply. 3x to the 2/3 times 4x to the 3/4. Ooh, exponents, fractions, you know, a lot of people are going to get scared of this. No, there's no point in that, no need. So first things first, the 3 doesn't have an exponent, so you have a 1. The 4 doesn't have an exponent, so you have a 1. Those are the coefficients for the powers. 3 is the coefficient for the power, 4 is the coefficient for the power. It doesn't have an exponent. Understand that? So we multiply those. If you remember that we just did radicals, those will be the outside with the outside. Okay? Whole numbers. 3 times 4 is 12. Now we do the powers. X to the 2/3 times x to the 3 over 4 is the same variable, so I keep the same variable. What do we do with exponents? 2/3, I add, right? X to the 4, remember this? Okay. X to the 2nd times x to the 3rd power. What do I do with the exponents? Add. X to the 2/3 times x to the 3/4, I add the exponents. So let me do that. 3 over 4. Here's the problem about rational exponents. That when we multiply powers, we need to add the exponents, and people get confused adding the exponents. Again, I have a link to the whole thing about fractions. Let's do it on the side. 2/3 plus 3/4. Okay? How do I do this? I need to have the same denominator. In order for me to add or subtract, I need to have the same denominator. 3 and 4 are different. I need the least common denominator. The easiest way how to do this is by multiply, by getting the same number of both. 3 times 4 is 12. So the fractions that I want, oh, this is too late. Let's get blue. My denominators that I'm looking for are 12. 3 times 4 is 12. So that will be my least common denominator. Now, how can I turn this 3 into a 12? By one number do I need to multiply? Yeah, by 4. 3 times 4 is 12. If I multiply the bottom, I multiply the top. So 4 times 2 is 8. 4 times 3 is 12. So 2/3 is the same as 8 over 12. Interesting. Red. How can I turn 3/4, but I needed 12 as a denominator? So by one number do I multiply the 4 to get 12? That's right, times 3. 4 times 3 is 12. Therefore, you multiply by 3 on the bottom, I multiply by 3 on the top. This has to be clear. 4 and 4, 3 and 3. Why? Because 4 divided by 4 is 1, so I'm not changing my fraction. 3 divided by 3 is 1, so I'm not changing my fraction, I'm just changing the way it looks. Let's go back. 4 times 3, 12, the denominator. 3 times 3 is 9. Once my fractions have the same denominator, I keep my denominator and I add the tops. 8 plus 9, 17. So final answer, x to the 2/3 times x to the 3/4. I add those two exponents and I ended up with x to the 17 over 12. And that's your final answer as a rational exponent. Okay? Let's do one more. Now we're dividing. You see, we're applying all the properties. Okay, again, 72 does not have an exponent, 9 does not have an exponent, those are the coefficients. 72 divided by 9, 72 divided by 9, 8. They just divide straightforward, okay? We don't have to play around subtracting, no. They divide straightforward, there's no exponents. Excellent. Let's go with the powers. X to the 3/5 divided by x to the 1/3. When I divide two powers, I keep the same base, I subtract. This is supposed to be a 5. Let's change that real quick. Okay. So when I'm dividing two powers, I subtract the exponent from the top minus the exponent from the bottom. And here's the problem. Okay, so I'll bring the 3 over 5 over here minus 1/3. I need the same denominator. What's the same denominator? The same denominator, the easiest one, minus, is multiplying those two. 5 times 3 is 15. That's the easiest denominator. That's my LCD. How can I turn 5 into a 15? Times 3. Whatever I do on the bottom, I do on the top. 3 times 3 equals 9. 3 times 5, 15. 3/5, same as 9 over 15. Minus 1/3. How can I turn 3 into 15? Times 5 times 5. Whatever I do on the bottom, I do on the top. 3 times 5 is 15. 1 times 3 is 3. Once I have the same denominator, I keep it and I subtract the top. 9 minus 3 is 6. Final answer, x to the 6 over 15. And that's it. Alright? Keep that in mind. The problem with rational exponents is not the properties, it is the fractions, adding and subtracting. So make sure you check the video about fractions. I hope you understood the process. Alright guys, again, subscribe to the channel, like the video, hit the notifications bell. Check those videos that I'm putting on the description, so that's going to help you out. And I'll see you next one. Take care.